So I'm here with another lesson. But before that, remember, long time ago, after 2 weeks, I think so, we discussed that angle at the center is twice angle the circumference. And we proved that theory, that angle at the center, this one, is twice angle at the circumference. If those angles are coming from the same chord, right? So this angle is twice this angle, meaning this angle times 2 is equal to this angle, or this angle divided by 2 is equal to this angle, right? So now I'm back. That one is the first theorem in the circle geometry. Now I have another lesson today that says that I want to prove that angle formed in a semicircle is a right angle, right? Or is equal to 90 degrees. Meaning that, remember, on properties of the circle, we discussed about the diameter, radius, and arc, sector, also equal. Yeah. So a diameter is a line that divides the circle into 2 equal halves or into 2 equal parts. Meaning that if this is a circle, right? If this one is a diameter, right? This diameter divides this circle into 2 equal parts or 2 equal halves. This one and this one, right? So those halves we call them semicircles. So we want to prove that any angle from the diameter here, from this point up this point, from this point up to this point, any angle formed from the diameter to the circumference of the circle here in a semicircle is a 90 degree angle. Meaning that we want to prove that this angle is a 90 degree angle. So that's why Mr. Nyanda is here again. So let's figure together, we need to prove that theorem, right? So let's start. Fine. Let me start with a drawing of a circle. Fine. Remember, I'm not a good drawer, but I'll try my best. So let's have a center here. Center O. And let's draw a diameter from this point through the center to that point on the circumference. So let's call it A, this one B, right? Remember, we want to prove that the angle from the semicircle is equal to 90 degree angle, or is a light angle, right? So, fine. So let's draw angle from the in the semicircle, but supposed to be from the diameter, this point and this point. So I will draw a line from point A to here and all the way to point B. Yeah. So we want to prove that. This angle is a 90 degree angle, or is a light angle, right? Remember, a light angle is equal to 90 degrees, right? So that's why we are here. So fine. So let's divide this diagram, especially the inner diagram, into 2 parts, right? Using a dotted line through the center. So let me draw a dotted line up to somewhere else here. Let's call this point D. Point D. Yeah. So remember, a radius. A radius is a line from the center of the circle to the circumference, right? Remember that, right? So this point, it's a center of the circle, and a line from O, which is center of the circle, to point A is a radius, right? A line from O to, okay, let's call this point C. A line from O to A is a radius, right? We know that. A line from the center of the circumference of the circle is a radius, right? So from point O to C, it's a line from the center square to the circumference. It's a radius again, right? Line from O to B is a radius as well. Why? It's a line from the point of the center, or from the center of the circle to the what? To the circumference of the circle. So all of them radiuses, right? Fine. So meaning that if O, C, and the OA, they are equal, meaning that this triangle ACO, is an isosceles triangle. Why? 2 opposite sides of an isosceles triangle, they are equal. Remember the first question I said that we'll use isosceles triangle mostly when proving those kind of theorems, right? So remember that. Meaning that this triangle, this line, and this line, they are equal. They have the same length. All of them. This one is a radius, and this one is a radius as well, right? Meaning that this triangle, triangle ACO, is it's an isosceles triangle. Meaning that the base angles of a triangle are equal, right? Meaning that this angle and this angle, they are equal, right? So they have the same value. So let's call this one x1, this one x2. I hope we are together, and we need to be together, right? This side as well, triangle OCB. OC is a radius as well. OB is a radius as well. Meaning that one property of the triangle is there, right? Meaning that the triangle OCB is an isosceles triangle. Opposite sides of our triangle are equal. Why? OC is equal to OB, right? Meaning that triangle OCB is an isosceles triangle. The second property is that base angles of an isosceles triangle, they are equal. Meaning that this angle and this angle, they have the same value, they are equal, right? So let's call this one y1, this one y2, right? So I think we should start now. We should start. Fine. So let's start with the triangle OAC, right? So here I will start with that using triangle OCY or CA or OAC. It's fine. Fine. We know that line OA is equal to line what? Line OC. Reason radii, right? Radii. Reason is radii. Fine. So meaning that triangle OAC is isosceles triangle. This symbol, remember, is an isosceles triangle, right? Meaning that triangle OAC is an isosceles triangle, right? Fine. So, and we know that angle OAC is supposed to be equal to angle what? Angle OCA. Reason, base angles. Base angles of what? Of isosceles triangle are equal. Base angles of an isosceles triangle are equal. That's why I said that this angle and this angle are equal, right? So what's the value of angle OAC? OAC is x2, right? X2 is equal to, what about triangle? What about angle OCA? OCA is x1. Meaning that x2 is equal to x1. Here we are together. I hope so. Fine. Okay, but how can we find out the value of this angle? Angle AOD. Remember that time I was explaining about the theorem that said that exterior angle of a triangle is equal to the sum of two opposite interior angles. Meaning that using triangle OCA, this angle AOD, this angle is an exterior angle of which triangle? The triangle OAC. Meaning that if one will find the value of this angle, which is angle AOC, this angle, an exterior one, we need to add this angle and this angle. Exterior angle of a triangle is equal to the sum of two opposite interior angles. Meaning that to find the value of this exterior angle, we need to add x1 and x2. Are you getting me? Yeah, I think we have get it. Fine. So let's do that. Fine. We know that angle AOD is equal to what? Angle what? Angle ACO plus angle what? OAC. Angle AOD, exterior angle, right? To find that the value of that angle, we need to add angle OAC, which is this one, plus angle OCA, exterior angle of a triangle is equal to the sum of two opposite interior angles, right? So this one is an exterior angle. Interior angle, interior angle. If you add them, we find the value of what? Of this exterior angle. So the reason here is that exterior angle, this one means exterior angle of a triangle is equal to the sum of two, sorry, this is two opposite. This one means opposite. Is equal to the sum of two opposite interior angles. I hope it's clear. Exterior angle of a triangle is equal to the sum of two opposite interior angles. Meaning that if you want to find the value of angle A or D, which is an exterior angle of a triangle OAC, we need to add the angle OAC in the angle ACO. X1 and X2 will find the value of this angle, right? Fine. Okay, let's proceed. Meaning that angle at A or D is equal to what? Is equal to what's the value of angle A or ACO? ACO is X1. What about the value of angle OAC? Angle OAC is equal to what? Is equal to X2. Meaning there will be X1 plus X2, right? Fine. But you know that triangle OAC, remember it's a what? It's an isosceles triangle, right? Triangle OAC is an isosceles triangle. Why? Base angles of a triangle are equal in their line OC and line OA. Those are the radiuses, meaning that two opposite sides of an isosceles triangle, they are equal. Sorry, it's bracket, but soon lights will be packed. Yeah, nice. So, meaning that this triangle OAC, remember it's an isosceles triangle. Why? This side OA and the side OC, they are equal. Remember, opposite sides of an isosceles triangle, they are equal, right? Fine. So we know that this angle, this triangle, is an isosceles triangle. And another property is that base angles of an isosceles triangle, they are equal, meaning that this value, this angle and this angle, they have the same value. They are equal, right? Meaning that X1 and X2, they have the same value. If X1 is 40, X2 is 40 as well. If X1 is 30, X2 is 30 as well, right? So we are adding the angles with the same value. If X1 is 30, X2 is 30 as well, right? So 30 plus 30 is what? 30 plus 30 is 60. What if we can take only one angle and you multiply by 2? The answer will be the same, right? So if we take X1 multiplied by 2, the answer will be the same as if the answer will be the same if we can add X1 and X2, right? So, for example, if X is 30, if X1 is 30, so 2 times 30 is 60. 2 times 30 is 60. So the result will be the same. If we can take 30 of X1 and 30 of X2, if we can add them, it's 60. So we'll take one angle and multiply by 2. The answer will be the same. So we'll take X1. So meaning that the angle AOD is equal to 2X1. Don't be confused. Engineers, don't speak there. We are here to solve problems, right? Yeah. You know that we can develop morale using this kind of stuff. Yeah. So this is the basic of engineering. So let's play together. Yeah, fine. So angle AOD is equal to X1, meaning that this angle is equal to X1. Yeah. So we need to go that side now of a triangle. We need to use the triangle OCB. So I know that it's fine. I can lump off this part, right? Fine. Fine. Now, using what? Using a triangle OCB. B. That side now, right? We know that line what? Line OC is equal to line what? Line OB. Line OC is equal to line what? Line OB. Why? OB is a radius. OC is a radius as well. They have the same length, right? A line from the center of the circle to the circumference is a radius. So line OC and line OB they have the same length. Reason radii. Because OC is a radius, OB is a radius as well. So the reason there is radii. Remember to put the reason, otherwise teachers will deduct the marks from their paper when they are marking. So remember to put the reason there, right? You can't do something without a reason. Yeah. So, and if line OC and OP they are equal, right? Meaning that triangle now is an isosceles triangle as well. Why? Two opposite sides of an isosceles triangle are equal, right? So meaning that if OB and OC they are equal, they are making this triangle. Meaning that triangle now, those lines they are making two opposite sides of that triangle. Meaning that two opposite sides of an isosceles triangle they are equal. Meaning that triangle OCB is an isosceles triangle. I hope we're okay there. Okay, fine. Meaning that triangle OCB is an isosceles triangle. Remember that symbol. Sorry, remember that symbol means an isosceles triangle, right? So, yeah, hope we're together. So, next. Okay, fine. We know that the properties of a triangle. The first one is that opposite sides of a triangle they are equal. Another one is that base angles of an triangle they have the same value. They are equal. So remember we said that this triangle OCB is an isosceles triangle, right? So meaning that the base angles of that triangle, which is an isosceles triangle, they are equal. So meaning that y2 is equal to y1. They have the same value, right? So meaning that angle OBC is equal to angle what? OCB. Reason base angles of isosceles triangle are equal, right? Meaning that what's the value of angle OBC? OBC is y2. What about the value of angle OCB? OCB is y1. Meaning that y2 is equal to what? Is equal to y1, right? These angles of a triangle are equal. Fine. But we have another angle beside this angle. That's the way we do it. This is an exterior angle over triangle OCB, right? Meaning that if you want to find the value of that angle, we need to use that theorem that says that exterior angle of a triangle is equal to the sum of two opposite interior angles. Meaning that we add y1 and y2 to find the value of this angle. Y is an exterior angle. y1 and y2 they are interior angles of that triangle, right? I hope we're together. Fine. Don't worry. Everything will be okay. So angle DOB. Angle DOB. Angle DOB is equal to angle what? Angle OBC plus angle what? OCB. Reason exterior angle of a triangle is equal to the sum of two opposite interior angles. An exterior angle of a triangle is equal to the sum of two opposite interior angles, right? An exterior angle of a triangle is equal to the sum of two opposite interior angles. Meaning, if we want to find the value of angle DOB, we need to add that. We need to add this angle y2 and y1 to find the value of that angle, which is exterior angle, right? So let's do it. Okay, fine. So angle DOB is equal to what? What's the value of angle OBC? OBC is y2 plus. What's the value of angle OCB? OCB is y1. But remember that triangle is an isosceles triangle, right? We have properties of a triangle. We have two properties of an isosceles triangle. The first one, two opposite sides of an triangle are equal. Another one is what? The base angles of an triangle are equal. They have the same value, the base angles, right? Meaning that y1 is a base angle that side, right? y2 is a base angle that side as well. Meaning that y2 and y1 they have the same value. If y2 is 30, y1 is 30 as well. If y2 is 50, y1 is 50 as well, right? So let's say y1 is 50, meaning that y2 is 50, right? So if you can add them, it will give us 100, right? Fine. Which is yeah, the value of y1 and y2 they are equal, right? So it's the same as taking one angle here and you multiply by 2. Why? If we can take y1 multiply by 2, it's like we are taking 2 times 1 times 50, which is 100 as well, right? So let's just take one angle here and multiply by 2. It will be the same as adding y1 and y2. So we'll take y1. Angle DOB is equal to what? Is equal to 2 times what? Y1. Meaning that here, the value of that angle DOB is 2 Y1. We are close to the answer. So don't worry. Fine. Fine. I hope I can laugh off here. Maybe laugh off. Okay, so remember angles in the straight line, right? Angles in the straight line. Okay, if we can help out, this one, A, B, C. The value of this angle is at 180 degrees. Why? Angles from the straight line is equal to 180 degrees, sorry. Meaning this side as well, 180. The complete change from here to here is 360 degrees. Why? We are taking this one 80 degrees and this one 80 degrees, adding them together 360, right? So we use this concept there. We use the same concept there, so don't be confused. Don't be confused. Fine. Okay, fine. We know that angle A or B is equal to 180 degrees, right? Angle A or B is equal to what? 180 degrees. Reason angles in a straight line. Angles formed in a straight line is equal to what? Is equal to 180 degrees. But angle A or D is equal to 2x, right? 2x1, sorry. And angle D or B is equal to 2y1. But if you can add this angle and this angle, we'll make a complete, it's like this, in short. We have point O here, A here, and B, right? It's like that. We have D here, right? Here. Remember that the whole of this angle is 180 degrees, right? Why? Angles formed in what? In a straight line is equal to 180 degrees. But we have the value of angle A or D, which is this part, right? Which is 2x1. And we also have the value of angle D or B, which is this side, which is what? 2y1. But we know that the whole of this angle is equal to what? 180. Right? Let's be together. Fine. We'll use the second set here to prove the theory. Don't worry. We are close to the answer. So we know that angle A or B is equal to 180 degrees, right? Fine. So and angle A or B is equal to what? If you want to find the value of angle A or B, we can add angle A or D plus angle D or B, right? We know that adding those angles will make a complete what? 180 degree angle, which is right? So angle A or B is equal to what? Is equal to angle A or D plus angle what? is what? 2x1. 2x1 plus. What about the value of angle DOB? DOB is what? 2y1. 2y1. Fine. So we know that 2 is common here, right? There's 2 here, there's 2 here. We can factorize. The simple mathematics, right? So it's 180 degrees is equal to what? 2x1 plus y1. How? 2 into 2x1 will mean what? X plus 1. 2 and 2 will cancel. 2 into 2x1 will remain with x1, y. 2 and 2 cancel, right? Here as well. 2 into 2y1 will remain with y1, y. 2 and 2 will cancel, so it will be 2 bracket x1 plus y1. If we can expand the bracket, you will get the same concept. You will get the same expression here, right? So yeah, it's fine. But you know that there's 2 here, there's 1 here, right? We can remove this 2 by dividing by 2 both sides, right? To make x1 and y1 along the side, right? So let's divide it. Divide by 2, divide by 2. This one will cancel. This one. 2 into 1, 8 is 90, right? Means that 90 degrees is equal to what? x1 plus y1. Here. Fine. So x1 plus y1. Okay, fine. Which angle the value is x1? That angle, right? Only this one. Right? Which angle the value is y1? It's this one. Only y1. Right? Meaning that x1 plus y1 is the whole of this angle. Right? The whole of that angle is x1 plus y1. If you can add this angle and this angle, if you can add these angles, those 2 angles, is x1 plus y1. But they're saying that x1 plus y1 is equal to what? 90 degrees. Right? x1 plus y1, that angle is equal to 90 degrees. Means that x1 plus y1 is equal to what? 90 degrees. If you can add those angles, means that the whole of this angle is equal to 90 degrees. But where the angle is formed? The angle is formed in a semicircle. In a semicircle. Why? This one is a diameter. So meaning that any angle formed in a semicircle there is equal to 90 degree angle, or is a light angle. We are done. There, since x1 plus y1 is the angle in a semicircle, then angle in a semicircle is a light angle, or is equal to what? 90 degrees. Because we are done with the proof, meaning that we can say QED. QED means quite easily done. The proof was very simple as long as you follow the procedure. Yeah. So that's how you can prove that the angle in a semicircle is like angle or is equal to 90 degrees. Of course, there's a short method, but I don't like it. Yeah, because you're supposed to follow good procedure, right? So let me prove that theorem using that simple or short method. Okay, fine. Method 2. Method 2 of the same theorem. Let's have a circle here. Let's have a circle. Diameter A, B. Let's have a center here. Center O. Let's create an angle in that same circle, right? Fine. Let's call this point C. Fine. Remember, angles in the straight line, right? Remember, angles in the straight line is equal to what? 180 degrees. Any angle can say that angle AOB is equal to what? 180 degrees. Sorry, it's supposed to be 180. Angle AOB is equal to 180 degrees. Why? Angles in this right. Angles in this one, right? Meaning that angle angle A or B, this angle is equal to 180 degrees. Right? Why? Angles from the inside right. But remember, the first theorem says that angle at the center, this angle at the center twice angle the circumference. As long as those angles are coming from the same chord, right? So this angle is formed from the diameter, right? And this angle as well is formed from the diameter as well, right? So this is the angle at the center. This is angle at the circumference, right? So we know that now angle AOB divided by 2 is equal to what? Angle what? Angle ACB. Reason angle at the center is twice angle at what? Circumference. Angle at the center is twice angle at the circumference. Let me write the way circumference for it quick. Thank you. Circumference. Angle at the center is twice angle at the circumference. Meaning that this angle times 2 is equal to this angle. This angle divided by 2 is equal to this angle, right? So here we have 180 degrees, right? Which is angle A or B. Will be 180 degrees divided by 2 is equal to what? Angle what? ACB. This ACB is the angle at the circumference. This angle AOB is the angle at the center. So if you can divide that angle, the angle at the center, if you can divide by 2, we'll find the value of this angle. If you can divide this angle by 2, we'll find the value of angle at the center, right? So 180 divided by 2 is what? 90 degrees, which is equal to angle ACB. Therefore, angles in the same circle is what? A right angle. Now we can say QED. QED means quite easy done. Why? They are done. Angle ACB. Angle ACB. ACB is an angle formed in a semicircle because this line A or B is a diameter dividing the circle into 3 parts. So this part, the upper part, is a semicircle. Meaning this angle ACB is an angle formed in a semicircle. ACB now. ACB is equal to what? 90 degrees. Meaning that we are trying to prove angles formed in a semicircle is a 90-degree angle or it's a right angle. Why? ACB is the value, okay, it's an angle formed in a semicircle. What's the value of ACB? 90 degrees. So that's another method, but yeah, try to use both, but the first one is better off. Yeah, so thank you for being here with me on in this question. So the next question, we'll start solving problems using those theorems. We have discussed about what I think it's 2 theorems, right, from trigonometry. The rest were the basics, right? So we'll be using those theorems to solve some questions using trigonometry. Yeah. So if you have some topics in mathematics, you can drop down there. You can write them on the comment section so that I should create a lesson for you, right? There is calculus. We can discuss about that, right? There is pre-calculus. We can discuss. There is number theory, Leo analysis. There is graph theory. There is group theory. We can discuss about that. Don't forget about computers, yeah, we can also discuss about computer. We can also discuss about the Excel, database using Access. Yeah, those ones we can discuss. Yeah, networking. Yeah, So don't be panic. Drop down the topics there on the comment section. Have a nice day.